Patient's here for a significant pulmonary embolism. The FiO2 is 60%. We're on ACPC. Peak inspiratory pressure is 18 and the PEEP is 10, which gives you a delta pressure of 8, which is quite safe. We have a 0.9 as an inspiratory time. We're going to check for any auto PEEP, and we can adjust that perhaps a little bit lower. We'll fine tune that. 7 to about 7 cc's per kilogram. She's a small lady. Volumes are hovering around 380 on average with a minute ventilation and normal blood gas. Compliance is decent with 44 on about, and resistance, we don't have any current issues with that. Let's do auto PEEP. 11.9 total. Give it a few breaths. Do another auto PEEP measurement. Pretty much the same at the moment. So let's leave this around 7.5. Didn't make much of a difference. She seems comfortable with the previous longer inspiratory time. Alright, so this is a PulmoVista we're going to go check out. This is a freeze frame image, so we see that good dorsal distribution of ventilation. It was 17. The smaller numbers are the reference. These numbers just happen to be the last breath that I froze. So we have 8 to 15% is the norm, so we're within normal limits here. We are also within normal limits in the mid-ventral and mid-dorsal regions, with usually 35 to 40 being the normal, as well as 8 to 15 back on the ventral area. This is the dynamic image. You see that there's a pretty decent distribution of the white intensity inside the blue. So blue begins to appear when there's greater than 10% of the distribution of ventilation. So when you have 395, you can multiply that by the percentages and find out the volume distributed specifically to those regions. The white intensity is where the maximum of ventilation. Overall, we don't have just this white clump of white showing that that area is taking the majority of the power from the vent. So overall, this is a normal, good distribution of ventilation. Patient, like I said, is currently on a PEEP of 10. So we're just going to titrate and do a PEEP study and fine-tune that PEEP level. Alright, so let's start the PEEP study going higher. This was at 10, so, oh yeah, sorry, vent settings. When you click this, there's going to be a link so you can keep the same drive pressures. With the PulmoVista, it's suggested to do it on ACPC, as well as increasing the PEEP by 2. You can do incremental, decremental, you can do whatever you like. So why don't we start at 10, we'll go up to around 14, and then we'll go back down to 6, and we're going to look at the different regional compliances to determine the optimal PEEP. Okay, so all we have to do is here, link, keeping a delta P of 8 consistently. So we're going to go up to 12, and we're going to wait for a bit. Alright, so we're up to 12. The compliance is 51, 54, 65. It seems to be higher consistently compared to the PEEP of 10. We can look on the video. I'm pretty sure that it was in the 40s. At least the first check I did, it was around 43 or 45. Alright, so we're going to go to screen settings up here. And we're going to press this, and we're going to link it, keep that delta P constant. Alright, we're at 14. Compliance 53, 48, 57. Going to wait a little bit longer. So this was a reference of 10. That was 17% dorsal distribution, and now we have 21%, so we'll keep an eye on that. Better distribution at the dorsal region slightly. look at that white intensity. So it's forming at least a pretty decent circle. Seems now that there's a little bit of loss in this region, and now you kind of have three circles instead of this consistent white intensity here. So definitely some distribution of ventilation has changed. We've increased the dorsal region. We've dropped we've dropped the ventral as well as mid-ventral. So it seems like it's slightly shifting down towards the mid-dorsal and dorsal region. So there's been a shift in ventilation in this respect. All right. Let's go back down now to 12. We're going to go down to around 6, unless it's quite obvious that we're seeing indications that, let's say at 8, it's already getting worse. We'll decide with the feedback from the vent how low we'll go. All right, so we went back down to 12, and now you have a return of remember there was like 3 blotches just a minute ago. Now it seems to be a lot more consistent here. So the distribution overall is better down to 12. Oh wow, yeah, it's pretty darn well distributed, the white intensity. All right, we're back down to 10. Let's check the PulmoVista out. This is on a PEEP of 10. I like how the white is very evenly distributed. So this was where we started from. So I'll be interested in seeing if 10 is optimal in compliance. It looks so just with the quick visualization. All right, that's perfect. Perfect distribution. Can't get better than that. All right, let's bring that down to 8. Give that a few minutes. So still a good distribution with the intensity. We're down to 19, 18, 19. So you notice with the lower PEEP, there's a slight return to the lower percentage. We had 21, remember, with the higher percentages. But that 21 didn't really distribute as evenly. So it's not necessarily better that we shifted things towards the base in respect to the even distribution. All right, we're down to 6. Still at 18 of delta P. All right, so down to 16% here. So PEEP of 14, we had 21%. So definitely less distributed to the dorsal region. Remembering the reference was 10, so then you go to view. The PEEP study has been done because we did the incremental PEEPs titrations going up by 2. Now we just press diagnostics. The computer can usually place them in the correct position. Sometimes you need to add a section, or you can press to adjust. But it did a pretty good following of the incremental. So you see the green line is PEEP. It's staircased up. So 10, 12, 14, 12, 10, 12, 14, 12, 10, 8, and 6. Then you press the PEEP trial. Orange means over distension or loss of compliance in that area. That's often can show up in the ventral regions, indicating over distension. The white areas indicate a loss of compliance to those areas with the lower PEEP titrations. And over here, this is a compliance loss. The orange saturation is represented also in percentage of compliance loss compared to the reference. So let's look at over here. The lines here, the vectors, are also the same numbers as here. So you have a quick look at the saturation. Then after you have a quick look at the percentages, then you look at the percentages plotted here. Here, where you have the cross section between the white and the orange will be where usually the optimal PEEP is set, and that gives you the least amount of compliance loss or white areas, and the least amount of compliance area for the orange areas. White here can mean cyclical opening and closing. Residual delay in ventilation can appear here. You can look at more details over here. So you see that with the lower PEEPs, there's actually some issues that show up as yellow. So you want also the yellow to be the lowest, and you can see that yellow starts appearing here with the lower PEEPs, and you don't get any of this from 14 to 10. So based on this information, it's going to be a PEEP of 12 that's ideal, offering the best compliance for that PEEP titration. Okay, so for this screen, it's the end inspiratory trend. You can actually also assess quite quickly if you're recruiting or de-recruiting. Remember that these are impedance values, and the more that impedance is increasing, the more aeration there is. The less impedance, the less aeration. So impedance overall is equivalent to volume. So underneath here would be kind of the functional residual capacity. Under these impedance curve represents the end expiratory volume quickly. And we can go to the next screen to go into more detail of the end expiratory volume. That's the other diagnostic screen that we can use. So we also have the PulmoVista connected to the Draker ventilator. So we have the timestamps here, as well as the PEEP, tidal volume, peak inspiratory pressure. So here, I put the reference here. These are the PEEPs. You see in green the staircases going from 10, 12, 14, 12, 10, 8, and 6. So we have here the reference comparing. As I scroll the control mode, it's going to represent all along the time span the differences in distribution. And the blue here that appears it is going to be a gain in that area compared to the reference. If there was a loss, you'd see it in orange. So this is, as we're in a PEEP of 6, we go up here to 12, sorry. So now you have an increase in the distribution towards the base. Remember, we kind of saw that when we were just looking at the main screen. Then after I go up here to 14, you see here 12. When I went from 10 to 12, you see the impedance increasing kind of trajectory upwards. So that means that recruitment was occurring over time between 10:37 and 10:42 over 5 minutes. We then increased it again. It obviously bumped up here, but it's holding straight, so no further recruitments occurring. Then we go back down over here to 10 from 12, maintains itself okay. Over here is PEEP of 10. It's still holding itself, but you see when we go to 8 and especially 6, definitely de-recruiting. And you can see also when we have the ideal PEEP over here, the 12 and 14, you see the 21% over here and the 17% as we went down to 6. Now you can also look at the end inspiratory trend. So the end inspiratory trend, you're kind of also able to see and follow yourself so you're not lost where you are. So this is 6. So when we went from 10 to 12, there was increased impedance and you were gaining volume. At the end of expiration, there was more volume residually here in the ventral areas, mid-ventral, a little bit more on the right dorsal over here. Let's keep on scrolling. This is a pretty big gain, and the impedance values, remember, volume equals impedance equals volume. So these positive impedance, you know right away that that can translate into actual increase in milliliters of tidal volume, or a volume residual at the end of expiration. If you want to know exactly globally, 0.92, if you multiply it by the reference tidal volume that's over here, you'll get the global impedance, the global amount of volume that's increased at the end of expiration, and then you can multiply each one of these by the tidal reference to get the milliliters of gain at the end of expiration for each region of interest from ventral to dorsal. And we went back down. Here you'll probably see a loss starting 12, okay, 10 and 10, no change. Kind of makes sense because you're comparing 10 to 10. But as you drop it below here, now you see that there is a loss in the ventral areas starting, and then after you see that it's becoming a significant decrease in end expiratory volume, which shows a significant decrease in that volume, which kind of translates and makes sense with the decreasing impedance curves here, as well as makes sense a good deal with the PEEP study also. So various ways of looking at the same information in a way. All right, thanks. Okay, so we started when we had a PEEP of 10 at 60% FiO2. And we were able, since increasing the PEEP to 12 based on the optimal PEEP study on the PulmoVista, we're down to 50%, and that's almost within half an hour of the adjustment. And we're satting 95, so hopefully that sat might go to 90, 96, 97. I can wean down to 45. So it'll be interesting to see over time, maybe in the coming hours, if we can further
have time to do the follow-up video on the oxygenation for the patient. So by the time I left, about 4 hours after titrating the PEEP to 12, I had the FiO2 down to 35%, and we were still satting 94. So just by setting and fine-tuning the PEEP, we had a great result. It went from 60 down to 35 in one shift, even less than one shift. And I also noticed that the compliance that was hovering around, 45, 50 on a PEEP of 10 went up to like 63, sometimes 70 on a PEEP of 12. And then PEEP of 12, 4 hours later, the compliance was up to 116. So that was kind of exciting. All right, see you guys. Merry Christmas.